Between the galaxies, between the stars, between everything you've ever known, there's nothing. And I mean absolutely nothing. Voids so massive that our entire galaxy would be a mere speck inside them. The Boötes void alone is 330 million light-years across, containing only 60 galaxies where there should be 2,000. That's not just empty space. That's a cosmic deletion on a scale that shouldn't exist. Here's what keeps astronomers awake at night. These voids aren't random. They're organized. They form a pattern called the cosmic web, with voids making up about 80% of the universe's volume. Think about that. 4/5 of everything is nothing. But here's the controversy that's splitting the scientific community right down the middle. Some scientists claim these voids are simply where matter never accumulated after the Big Bang. Others? They're not so sure anymore. Recent observations from the Sloan Digital Sky Survey have discovered something that challenges everything. These voids are growing. The KBC void, which we're apparently living on the edge of, is expanding at a rate that doesn't match our current models of cosmic evolution. It's 7 times larger than average voids, stretching 1 billion light-years across. And according to 2019 research, it might explain why our measurements of the universe's expansion rate keep contradicting each other. Let me interrupt your thinking right here, because what I'm about to tell you sounds like science fiction, but it's peer-reviewed science. In 2015, astronomers detected something they called the cold spot in the cosmic microwave background radiation. This spot is colder than it should be, and one explanation is that it's caused by a supervoid 1.8 billion light-years across. But here's where it gets weird. The mathematics don't fully work. The void isn't large enough to explain the temperature difference, which means either our physics is incomplete or something else is going on. So what actually created these cosmic empties? The standard explanation goes like this. Right after the Big Bang, 13.8 billion years ago, matter wasn't distributed evenly. Tiny quantum fluctuations created regions of slightly higher and lower density. Gravity pulled matter from low-density regions into high-density regions. Over billions of years, this created the cosmic web we see today, with dense filaments of galaxies surrounding enormous voids. But stop right there. This explanation has a massive problem. Computer simulations based on this theory predict void sizes and distributions that don't match what we actually observe. The voids are too empty, too large, and too perfectly organized. In 2020, researchers at Yonsei University in South Korea found that voids are more spherical and more evenly distributed than random chance would allow. That's not how chaos works. This is where dark energy enters the conversation, and it's not what you think. We know dark energy makes up 68% of the universe and drives cosmic acceleration. But new research from 2023 suggests dark energy might not be constant. It might be stronger in voids than in dense regions, actively pushing matter away and making voids expand faster than they should. If this is true, voids aren't just empty spaces. They're dark energy laboratories, showing us how this mysterious force actually works. There's another theory that sounds radical, but has serious scientific backing. What if voids aren't really empty? Theoretical physicist Laura Mersini-Houghton proposed that voids could contain massive amounts of dark matter structured in ways we can't detect yet. In 2022, gravitational lensing studies found unexpected mass signatures around void edges, masses that aren't accounted for by visible matter or our current dark matter models. These void walls contain galaxy superclusters, but there might be something else there too. The most mind-bending possibility comes from multiverse theory. Yes, multiverse. Some cosmologists seriously propose that voids could be imprints left by other universes pushing against ours before inflation, those first fractions of a second after the Big Bang. These collisions would create regions where matter was expelled, leaving voids behind. Sound crazy? In 2016, researchers identified 4 circular patterns in the cosmic microwave background that match predictions of such collisions. The scientific community is still fighting over this interpretation. Here's what we know for certain as of 2024. NASA's James Webb Space Telescope is finding galaxies inside voids that are older and more developed than they should be. These galaxies formed when the universe was only 500 million years old, which contradicts our timeline of structure formation. If voids are truly matter-starved regions, these galaxies shouldn't exist, or they should be primitive. They're not. The Euclid Space Telescope, launched in 2023, is now mapping the cosmic web in unprecedented detail. Preliminary data shows that void edges are sharper than predicted, with matter distribution dropping off almost like a cliff rather than gradually. This suggests something actively maintains void boundaries, something beyond just gravity and expansion. What this means is humbling. These voids, these cosmic nothings, might be the key to understanding dark energy, dark matter, and the ultimate fate of the universe. If voids are growing and accelerating, our universe will eventually become mostly nothing, with island galaxies separated by incomprehensible distances, alone in an ocean of void. The creation of cosmic voids isn't a closed case. It's an active mystery involving the strangest physics we've ever encountered. Every new observation raises more questions than answers. So if you find this fascinating, follow for more mind-bending space mysteries that challenge everything we think we know. Now here's my question for you. If voids make up 80% of the universe, and we don't fully understand how they formed or what's in them, can we really say we understand the universe at all?